Working in AI safety is often misunderstood as solely a task for computer scientists, but the reality is far more expansive. As artificial intelligence accelerates, a diverse ecosystem of careers has emerged dedicated to mitigating catastrophic risks. This landscape bridges the gap between theoretical philosophy and practical engineering, requiring a unique blend of skills to ensure advanced systems align with human interests. The foundation of this work, however, begins deep within the algorithms themselves. For those with strong computer science backgrounds, technical alignment research is the primary entry point. This work focuses on ensuring advanced models reliably follow human intent, even as they become smarter than their creators. A crucial component is interpretability, which involves decoding the complex internal states of neural networks to understand exactly why a model makes specific decisions. Yet, fixing the code is only half the battle when the global rules for AI are still undefined. While researchers engineer the safety mechanisms, governance experts determine how they are enforced globally. This career path focuses on translating complex technical risks into actionable legislation and international treaties. Professionals here work to prevent a dangerous race to the bottom by establishing safety standards that all labs must follow. Yet, passing laws is useless without infrastructure. We now turn to the operational architects who build the organizations where this critical work takes place. While researchers push boundaries and policymakers draft laws, a crucial engine runs in the background. Operational roles act as the backbone of this ecosystem. Field builders grow the community by organizing talent pipelines, while program managers ensure frontier labs operate efficiently. These professionals provide the infrastructure for safety work to scale. Yet, to truly succeed in any of these positions, one must first master the rigorous technical foundations that underpin the entire industry. While program managers build the infrastructure, the core research demands rigorous technical fluency. You cannot effectively align a system that remains a black box. This requires a deep command of machine learning architectures, particularly transformers and reinforcement learning, to anticipate failure modes. Furthermore, formal verification is surging in importance, using mathematical proofs to guarantee safety constraints. Yet, having the engineering chops to build these systems isn't enough to determine exactly how they ought to behave. Because technical prowess alone cannot solve value alignment problems, successful candidates ground their work in rigorous philosophical ethics. Researchers must grapple with complex moral frameworks to determine exactly which values a system should maximize. Strategic thinking is equally vital, requiring experts to predict how advanced agents might deceptively pursue goals or alter geopolitical dynamics. This rare blend of foresight and reasoning is exactly what specific high-impact organizations are looking for right now. Once you possess these strategic and technical skills, the question becomes where to apply them. Frontier organizations like Anthropic, Google DeepMind, and OpenAI are at the forefront, requiring rigorous empirical safety work. Meanwhile, academic institutions such as Oxford and Berkeley drive foundational theoretical research. For those inclined toward policy, nonprofits and think tanks offer a path to influence governance. However, landing a role in these competitive environments often requires more than just a traditional resume. Getting hired by top labs rarely happens through a standard application. The ecosystem relies heavily on specialized on-ramps like the CIRIMATS Fellowship, research residencies, or independent grants from funding bodies like Open Philanthropy. These unique channels allow candidates to prove their technical alignment capabilities through direct project work rather than traditional interviews. Successfully navigating these competitive entry points places you directly on the trajectory to shape what this workforce looks like in the years ahead. Beyond these initial entry points, the long-term horizon is incredibly dynamic. Demand for safety researchers is scaling directly alongside model capabilities. We are approaching a future where safety is not merely a niche department, but the central pillar of development. Whether you focus on technical alignment or governance, the ecosystem is rapidly maturing. The work you do today will not just shape a successful career, it will likely help determine the trajectory of human history.